This is my fixture. It's not particularly efficient or anything, it's just what I've been using. I've got 4 dowels put in positions. These are like 3/8 of an inch apart, and these I believe were 1 inch, 112 thousandths. So I put a 1/4 20 bolt. Here's a 1/4 inch spacer, and then take the end of my coil of wire, or my spool of wire. I fish in about, I don't know, 6 inches or so. Put that on here. Then snug down a bolt. And I got a spacer just to clear this bolt head. And just put some screws in here to hold the whole thing to my pivot. 97, 98, 99, 100. Okay, and then I just tape this off like that. Clip my wire. And I just put a little pigtail on it so I know that this is the end of the coil. The tail's the end of the pig, so the pigtail's the end of the coil. I unscrew this, I carefully pull this off, and then I lace it up with string. And the coils end up looking like this. Here what I've done is I've finished winding 12 coils, and I took a board and penciled in where I'd like the coils to sit, and I sort of clamped them in place with this board here. And I've numbered them 1, 2, 3, 1, 2, 3, and so on around. And what I'm doing is I've done the first phase already. I'm taking, say, the tail end of this one, connecting it to the start of that one, and working my way around. And I'm connecting up the 3 phases. So I'll connect every 3rd coil, going head, tail, head, tail, head, tail, or start, finish, however you want to think of it. And just soldering them up, and I should end up with 6 wires, 2 for every phase. You can kind of see a little smoke come off from it when it gets hot enough. I'm careful not to light anything else. After I'm done with a phase, I check it. I'm just using this terminal block to make sure I have good electrical connection. I'm showing a little bit, somewhere between 5.2 and 5.3 ohms. Here I've made my form for pouring the resin. I just made a dam out of some modeling clay to the diameter I want. I've got spacers, so when I clamp the boards together, it'll set me at 3/8 of an inch. And what I'll do is I'll lay a layer of glass cloth, put the coils on, put a couple more layers of glass cloth in the center for strength, and then cap it off with another layer that covers the whole disc. and then put some wax paper on, and then the board, and clamp it down. Here's the stator after I've demolded it and cleaned it up a bit. I wish I could say the whole molding process was well thought out and well executed, but there was a certain element of panic involved. But anyhow, I have a flat disc, and it appears to be the right thickness, and the coils are in place. So I'm going to drill some mounting holes, attach some wires to these to extend them, and reassemble the generator. Here's the completed generator with the plate. What I've done, it's a little hard to see, but I've connected all the tails together, and so that forms a Y configuration, and I've got 3 phases coming off, and got my leads on each end of the phase here, with the ground going to the center of the Y. So here's the output of the generator. If I give it a little bit of a spin and I trigger it, we get this sort of a signal. Channel 1 is my first phase, and we can see that, that's the channel 1 right there. And if we want to take a look at what kind of voltage we have, can put the first cursor down at the bottom and the second cursor at the top, and we're showing a delta voltage peak to peak of 9.2 volts. Of course, in the final assembly we're going to rectify this so it would be half that voltage. If we change our cursor back to time, we can put the cursor on one peak there, second cursor on that peak. We're showing a delta time of 146 milliseconds, which is 6.8 hertz, which works out to be a little less than 60 RPM. I've switched over to channel 2 to the third phase, so I'll give the turbine a spin, trigger it again, and this is our output. You'll see now channel 1 appears a little bit to the left of channel 3, so I guess that would, or of channel 2, so I suppose that would mean phase 1 is leading phase 3. Take a few measurements here. Time measurement showing a difference of 136 milliseconds, or 7.4 hertz. It's getting close to 60 RPM. Change to voltage. Showing a peak to peak of about 9.68 volts. And of course that gets rectified again. So anyway, there's the output. Time to make a rectifier circuit for it and hopefully get some useful current out of it.